So again, anytime we have any set of ordered pairs, just a relation, the domain is going to be our first components, or usually the x's, range is the second components of the ordered pair, which is usually the y. All right, so if we're given just ordered pairs, domain and range is pretty straightforward because remember our definition for domain is the first component or the x's. So if we're looking at our ordered pairs that are listed there, we're just going to state out the x values in our solution sets. So as you're taking notes on this, you probably want to write down the original ordered pairs so that you know where we're going to get our answers from. So again, knowing that our domain is the x values, all we have to do is write out the x values for each of these ordered pairs. And I'm going to put them in the solution set brackets. We want to try and go from smallest to largest. So our smallest x is 0, and then 10, 20, 30, and 42. Our range then, by definition, is the y values. So all we're going to do is write out the y values. Again, making sure we are putting it from smallest to largest, however. So our smallest y value is 6.7. And then we go 9.1, 10.7, 13.2, and 21.7. We will get into more domain and range tomorrow, but for right now, domain and range of ordered pairs. We're also going to be talking about functions. So for a function, the definition, remember, is each x has one y. So if your x value has just one y value, then it's a function. So if we're looking at these ordered pairs, okay, all it's saying is this a function? So if we go back to our definition, does each x have just one y? So here we have an x value of 1. It has a one y value of 2. If we look at the ordered pairs, there's no other x values of 1. So that x value of 1 has one y value. We go to the next one. This x value of 3 has a y value with it. There's no other x values of 3, so we're good with that. As we get to the next one, we have an x value of 5 with one y value. But if we look right next to it, there's another x value of 5 with a different y value there. So that x value of 5 has two different outputs. So that one's not a function. Again, the reason it's not a function is the x value of 5 has two y values. And for it to be a function, each x has to have just one. For b, again, we're just looking. Here's an x value of 1. It has one y value, and there's no other x values of 1. Here's an x value of 3. It has one y value of 4. There's no other x values of 3. Here's an x of 6. It has one y value. There's no other x's of 6. And here's an x of 8 with one y value. There's no other x values of 8. So in this case, all those x values are different, and they all have just one y value that goes with it. So it is a function. All right, next set looks like if I'm giving you an equation, okay, how can you determine if the equation is a function or not? So the first thing you're going to do is get the y by itself. And then we're going to look how many answers or how many outputs would we get if we plug a number in. So again, first thing we're going to do is get the y by itself. So anytime we're getting the y by itself, we do our PEMDAS backwards. We're undoing. So here's the y. I need to get rid of that addition or subtraction. So it's a plus 2x. So first thing I'm going to do is subtract 2x. So now that the y is by itself, no matter what I plug in for x, how many y's am I going to get out? Just one, right? If I plug 0 in, negative 2 times 0 is 0, plus 6 is 6, 1 y. If I plug 10 in, negative 2 times 10 is negative 20, plus 6 is negative 14. I get one y value out. So this is a function because no matter what you plug in for x, you get one y value out. And then for b, again, we have to get the y by itself. So I'm going to undo addition subtraction first. I'm going to try to get this y by itself. So the x squared is being added. So the first thing I'm going to do is subtract the x squared. And that would give me y squared equals negative x squared plus 1. The y is still not by itself yet. It's close. So what do we have to do to get rid of the square? You got to square root both sides. Yep. So the square and the square root cancel here. Since this is two separate terms, I can't simplify this. I have to leave it as negative x squared plus 1. But remember, when we write that square root to solve, how many answers do we get? 2. We need that plus or minus in front. So because of that plus or minus in front, when I plug something in for x, how many y values am I going to get out? I'll get 2 answers out because it's plus that square root and then minus that square root. Meaning, would this be a function or not a function? Not a function. So for each x value, you get 2 y values. All right, and then you can try this one on your own here. All right, so the first one we'd have to take the square root to get the y by itself. Remember, when we take the square root, we get how many answers then? We get 2 answers. So we get plus or minus the square root of x here. Because that plus or minus, we'd have not a function. For the second one, we already have the y by itself, right? Now, even though these look similar, they both have square roots, there's a huge difference between the first and the second. The first one has that plus or minus in front. This does not have a plus or minus in front. So here, if I plug in 4, 4 plus 5 is 9, and I'm taking the square root of 9, which is just 3. Okay? If the equation wanted you to do plus or minus both of them, you'd have to put plus, you would see plus minus. Or if they wanted just the negative, you'd see them negative in front. But because this is already given to you, it's assumed to be just the positive. So therefore, this would only give you one answer. This would be a function. And again, the example, if I plug 4 in, I'd be saying the positive square root of 4 plus 5, which is the positive square root of 9, which would just give you positive 3 here. So when you're solving for y, getting the y by itself, that's when you use the plus or minus. If the equation's already solved for y, whatever sign you see in front is what you have. All right, and then the last thing is pretty straightforward. The vertical line test is a way that you can also help determine if something's a function, particularly for a graph. Okay, so I know you guys did vertical line test before, but if you might want to make a note of it, remember if any vertical line intersects the graph at more than one spot, then the graph is not a function. Okay, it's not a function if it crosses at more than one spot. So you can either draw vertical lines, you can take your pencil and make it vertical and go across, whatever you want to do. But if the vertical line only touches each part of the graph at one spot, function, more than one spot, not a function. So for A, no matter where I drew a vertical line, that vertical line is only crossing at one spot. This is close, but it is constantly going outward. Okay, so this one would be a function. Again, there is very close, but it's only touching at one spot there. For number 2, here, if I draw a vertical line right there, it's crossing at 3 spots, meaning this would not be a function. All right, take a moment and do those C and D then. You talk with your partner. All right, good. C is a function. No matter where you draw it, you would have the vertical line cross at one spot. D, right there, is crossing twice, so it's not a function. All right, so what you're working on right now, and you should have a good amount of time to work on it. Page 230, numbers 1 to 25 odd, and then 55 to 63 odd. Take close note for the first set, 1 to 9 odd. It says determine if it's a function, and then state the domain and range. So you need 3 answers for 1 through 9 odd. Is it a function? And then domain and range.